Now, here I am going to tell you the relation between this glancing angle and angle of deviation So already we have the relation between the glancing angle of incidence and angle of deviation. I take this formula here. D is equal to 180 degrees minus 2i. What is D refer? Angle of incidence. What is I refer? Angle of incidence. From the figure, we know that I is equal to 90 minus Ig. Hence, we are writing I is equal to 90 degrees minus glancing angle. Okay. Whenever we write this value in the place of I, then we get D is equal to 180 degrees minus 2 into, in the place of I am writing this 90 minus Ig, 90 degrees minus Ig, glancing angle. Then D is equal to 180 degrees minus, expand it, 2 into 90, 180 degrees, and minus into minus plus 2 into Ig, 2Ig, 180, 180, minus 180, both are cancelled, 0. Then D is equal to 2Ig. This is the relation between angle of deviation and glancing angle. Okay, so these relations are very, very important. So please children, remember the formulas. Relation between angle of incidence and angle of deviation gives this formula. Okay, relation between angle of incidence and glancing angle given by these formulas. Relation between deviation and glancing angle is given by this formula. And we know very well angle of glancing angle is equal to glancing angle of incidence is equal to glancing angle of reflection also. Since Ig is equal to Rg, we can write D is equal to 2Rg also. Okay, so please remember all these formulas. These formulas are very helpful to solve the problems further. Okay, please note down this derivation part. Fast. Now, the last basic thing, characteristics of image. An image formed by a plane mirror. So an image is formed in the plane mirror. What are the characters it has? We have discussed in previous class. Object distance is equal to image distance. Object distance is denoted by U. Image distance is denoted by V. Object distance is equal to image distance, or distance of object is equal to distance of image. Next, height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is denoted by HO and height of the image is denoted by HI. And third character, image is virtual and image is erect. Image is virtual, image is erect. And the last character, image suffer lateral inversion. So this is actually in some books they don't agree lateral inversion. Okay, so vertical left right inversion they don't agree, but okay, we have this is in the academic textbook, that is why we are following this. Now I'll explain one by one. For example, This is a plane mirror. We have placed an object here. This is O dash. This is equal to height of the object. Okay. So from the tip of the object, let us imagine a ray coming to meet the mirror. Actually, from the tip of object, many infinite light rays are coming to meet the mirror. Infinite. But for better understanding, to make not the diagram clumsy, we have considered only some rays. Okay. And one more ray I will consider. This is another ray. Okay. Now, what happened? This is incident ray. This incident ray incident perpendicularly. Since it is incident perpendicularly, after reflection, it traces the same path. It goes this way. But here when we draw the normal, here this is normal. This is making certain angle, that is called angle of incidence. Light always obey the laws of reflection. So what happened? This ray reflects in such a way, it makes the angle which is equal to the angle of incidence. This is a reflector ray. This makes some angle which is equal to the eye. Here also, a ray coming to incident on the mirror. From this point also, many light rays coming to incident on the mirror. I considered this one. And I am taking this one, another one. Okay. See, this is incident perpendicularly. So what happened after reflection? This traces the same path, goes back in the same path. But here we draw the normal. This makes some angle, that is angle of incidence. So this ray makes equal angle. During reflection, it makes equal angle to the angle of incidence. This is angle of reflection. This I and R equal, here I and R equal. Then what do we do? To understand the formation of image, we have to extend them backside. Actually, after reflection, light rays are going this way. In reality, light rays never come back after the mirror, behind the mirror. It is not possible. For understanding the formation of image, we are just imaginating the extrapolating lines, imaginary lines we are drawing. So if this light ray continuously goes this way, if this light ray comes back after reflection, goes this way, right? If I extend this, it comes this way, okay, and meet here. So this ray and this ray both are meeting, these both reflector rays are meeting this point. This point is the I dash, which is the image of the O dash. I dash is the image of O dash. In the same way, when we extend this incident ray, this reflector ray backside, and this reflector ray also backside, they will meet at this point. They meet at this point. Here, this point is I. I is the image of the O. I dash is the image of O dash. The remaining points, they forms their respective image between these 2 points. And finally, the complete image of height of this object is formed here. Now you see, this is object, this is image. What is this? This is object. What is this? This is image, which is formed in the plane mirror. First one you see, distance of object is equal to distance of image. What is distance of object? The distance between mirror and object. This is called object distance. And this is image distance. Both are same. Height of the object is equal to height of the image. You see, this is the height of the object, and image also has same height. Height of the object is equal to height of the image. And image is virtual. See, generally, rays coming from the object after incident on the mirror, if they diverge, they do not meet. See, if I extend this reflector ray, this ray goes this way and this ray goes this way. Do they meet? There is no chance of intersecting. In this case, in this particular case, what happened when we extend them backside of the mirror, behind the mirror, they meet. They are not actually meeting. We are drawing. So is it real? No, it is virtual. So virtual image is formed due to the diverging of light rays after the reflection. If the rays diverges, which image is formed? Virtual image is formed. Okay, I will make it more clear here. For example, this is one plane surface. This surface has some elasticity, so we can bend in any direction. So by exerting some force on both ends, I make this way. Imagine some number of light rays are coming to incident on this. So same rays coming to incident on this. Yes. What happened now? After reflection, all the light rays meet at one point. This is the image. Here image is formed before the mirror, because rays are converging after reflection. This kind of image is called a real image. I will bend this one in this way. Okay, when I bend that one in this way, you see, same light rays, when incident on it, what happened? So since the surface is this way, after reflection, this one goes this way, this one goes this way, this one traces the same path. Okay, now are they meeting after reflection? There is no chance. They are deviating. Then what do we do now? We will extend them backside. Now here image is formed. Here image is formed due to the imaginary lines which we have drawn. Is really rays are coming towards backside of the mirror? No. So this kind of image is called what, Nana? Virtual image. So in the plane mirror, our dressing table mirror, what kind of image is formed? Virtual. Because after reflection, rays are diverging. We have to extend them backside. These are not real. Really, they are not coming back. After reflection, they goes this way. We are extending them backside. After reflection, if the rays diverge, virtual image is formed. After reflection, if the rays converge, real image formed. After reflection, if the rays diverge, virtual image is formed. Here rays are diverging after reflection. So virtual image formed by the plane mirror is virtual. Plane mirror is a mirror that we see every day. Our face every day we see in the mirror, dressing table mirror, that is the plane mirror. Now image is erect. Erect means, you see, if I keep the marker this way, the image also form this way. If I keep the marker this way, image cannot form this way. This is erect. This is inverted. This is called inverted. This is called upright. If I keep the marker this way, image also form this way. Image doesn't form in opposite direction this way, sir. This is called inverted image. But can we see the inverted image? No. When we stand in front of the dressing table, what kind of image we see? Upright image. So the image formed by the plane mirror is erect. It is also called upright. And image suffer lateral inversion. That means what? Whenever we raise our right hand, it seems to be left in the mirror. Whenever we raise our left hand, it seems to be right in the mirror. Okay? So that is illusion. There is no reality. Okay? Image suffers lateral inversion. Okay? These are the characteristics of the image formed by which mirror? Plane mirror. Why I recalled all these characters image formed by the plane mirror? Because we have two types of curved mirrors in this lesson. One is concave mirror and other one is convex mirror. These mirrors also form the images. When we compare the images formed by the plane mirror with these mirrors, we will understand the lesson in easy way. Okay? Now I will take this concave. For example, if you take spoon, which we are using, it's a ladle during the cooking process. Okay? To make the items, to mix the items in a vessel, we use one metallic item that is called a ladle. Right? The spoon shape is like this. When we see this way, our image is completely inverted in that. Have you ever observed? When we stand in front of the steel pot, our image is completely inverted. So when surfaces are curved, when we see our images are not same size. Image may be diminished, image may be enlarged, image may be inverted. So different characters, that image has different characters, right? To understand that characters, first you have to understand general characters of image formed by the plane mirror. I hope you understand. Please note down all these characteristics of image formed by the plane mirror. So now we are entered actual chapter, reflection of light at curved surfaces. Till now we have discussed some important basics for understanding this lesson in easy way. Okay. So now I am going to introduce concave mirror and convex mirror. I will make it simple. For example, there is a fish pot which is made of glass that is spherical in shape this way. Okay. When you hold this, when you are during traveling, when you hold this, okay, accidentally, if it slips from your hand, what happens? It breaks because it is made of glass. Now you collect one of the piece and observe that piece. This one is broken, right? When you observe the piece, will you find the surface is plane? No. You will find the surface is curved this way. Isn't it? So it has curved surface. We consider two surfaces it has. Okay, the shape is curved one, it is not the plane one. Okay, it has two surfaces. This is called inward surface and this is called outward surfaces. How many surfaces we do have? Inward surface and outward surface. Now I am going to take the same part of the spherical mirror. Okay, this outward surface is silvered. So we applying some silver coating on the complete surface and after that we paint it. So that is called silvering. In simple word, it is called silvered. Okay. Then what happened? Which surface act like a mirror? Outward surface is silvered. So inward surface act like a mirror. If the inward surface is act like a mirror, that is called concave mirror. See, this is plane surface. Okay, this is inward surface, this is outward surface. Okay, now you see this surface is act like a mirror. Okay, this is behind the mirror, this is before the mirror. This surface which is act like a mirror is bent inwards. Okay, the surface which act like a mirror is bent inwards. That is called concave mirror. And this one you see, same part of the mirror. Now we are going to silvering on the outside, inward surface. Inward surface is silvered. When inward surface is silvered, then outward surface is act like a mirror. Now this is. So this surface is silvered and this surface act like a mirror. Okay? This is silvered. Now this surface act like a mirror. How is this surface bent outside? So surface of the mirror, the reflecting surface of the mirror bent outside or outward, that is called a convex mirror. The reflecting surface of the mirror which bent inward, that is called concave mirror. The reflecting surface of the mirror which bent outward, that is called convex mirror. So for concave mirror, inward surface act like a mirror. For convex mirror, outward surface act like a mirror. Okay. So if I draw the concave mirror this way, concave mirror also can be drawn this way. Now which is the inward surface? This is inward surface, this is outward surface. For concave mirror, outward surface is silvered, inward surface act like a mirror. So here which surface should be silvered? Outward surface. This is outward surface, this should be silvered. So inward surface act like a mirror. And for concave mirror, we have discussed now convex mirror. For convex mirror, inward surface should be silvered, then outward surface act like a mirror. Okay. So while we are talking about these concave mirror and convex mirror, sometimes we place the mirror left side, sometimes we place the mirror right side. According to Cartesian rule, we are placing the object left side at that point of time. I will show the mirrors this way. Okay. So that is why in any manner you have to understand this is convex mirror and that is convex mirror. The definitions of both these concave mirror and convex mirror I will write on the board. Please copy. Concave mirror, the reflecting part of the mirror which bent inside inwards is called concave mirror. Convex mirror, the reflecting part of mirror which bent outwards is called convex mirror. So these are the two definitions of the concave mirror and convex mirror. In coming class, in the next class, we are going to understand the important terminology which is related to the spherical mirrors: pole, principal axis, center of the curvature, radius of the curvature, focal point, or it is also called focus, principal focus, focal length. So these are all the important terminology which is related to these mirrors. If you understand this terminology, then the remaining part of the lesson, it is very easy. So we discuss these in coming class. So thank you children, have a nice day.